Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Calculus series and concerns using trigonometric formulas in integration. This guide outlines some useful methods in integration which use trigonometric formulas. It shows how these formulas can be used to simplify some seemingly complicated integrals involving sines and cosines. Introduction. Integration is a rich and varied subject which proves to be more intricate and wide-ranging than its counterpart, differentiation. By learning a few basic rules, you can differentiate almost every function. See study guides, differentiating basic functions, the chain rule, the product rule, the quotient rule. Integrating commonplace functions is not so straightforward, and to become proficient in integration, you need to have a wider range of techniques at your disposal. See study guides, integrating basic functions, definite integrals, integration by parts, integration and natural logarithms. The mathematical subject of trigonometry, the study of triangles, see Steps into Trigonometry, offers you many useful relationships in the form of trigonometric formulas or identities, which help solve seemingly difficult integrals. It is helpful to learn to recognise the form of integrals where the following methods apply, and to have a good knowledge of a variety of helpful trigonometric formulas. The fact sheet, Trigonometric Identities, can help with this. Basic integrals of sine and cosine. Many methods in this guide will produce an integral of either the sine or cosine function, and it is worth reminding yourself of the following indefinite integrals. The integral of a multiplied by the sine of kx with respect to x equals minus a divided by k multiplied by cos of kx plus c. The integral of a multiplied by the cos of kx with respect to x equals a divided by k multiplied by sine of kx plus c. Double angle formulas. The double angle formulas are used to convert the integrals of either sine to the power n of x or cos to the power n of x, where n is a positive even number. When n equals 2, you can use the formulas directly, but when n is larger, you will have to expand brackets and the formulas repeatedly. The double angle formulas are sine squared of a equals 1/2 minus a half multiplied by the cosine of 2a. Use this with sine to the power n of a when n is even. Cos squared a equals a half plus a half multiplied by cos of 2a. Use this with cos to the power n of a where n is even. Example. Find the integral of cos squared x with respect to x. Making a direct substitution using the double angle formula, cos squared a equals 1/2 plus a half multiplied by cos 2a, with a equals x, you get the integral of cos squared x with respect to x equals the integral of 1/2 plus a half multiplied by cos 2x with respect to x. You can split this integral into two separate integrals. The integral of a half plus a half multiplied by cos 2x with respect to x equals the integral of a half with respect to x plus the integral of a half multiplied by cos 2x with respect to x. The first integral is found using the power rule, and the second integral is the basic cosine integral on the first page of this guide, with a equals 1 and k equals 2. Therefore, the integral of a half plus a half multiplied by cos 2x with respect to x equals the integral of a half with respect to x plus the integral of a half multiplied by the cosine of 2x with respect to x, which equals a half of x plus a quarter of sine of 2x, the constant of integration c. You can check your answer back by differentiation. Example: find the integral of cos to the power 4 x with respect to x. Firstly, you can write cos to the power 4 of x as cos squared of x all squared. Now you can use the double angle formula on cos squared x in a similar way to the previous question. And so, after expanding the brackets, you get cos squared x all squared equals a half plus a half of cos 2x multiplied by a half plus a half of cos 2x, which equals a quarter plus a half of cos 2x plus a quarter of cos squared 2x. You can see that the third term is also a cosine squared term, and so you can apply the double angle formula for a second time, now with a equals 2x, to get a quarter of cos squared 2x equals a quarter multiplied by a half plus a half of cos 4x, which equals 1/8 plus 1/8 of cos 4x. And so, after using the two results above and adding the fractions, the integral can be written as the integral of cos to the power 4 of x with respect to x equals the integral of 3/8 plus a half of cos 2x plus an eighth of cos 4x with respect to x. You can split this integral into three separate integrals. The integral of 3/8 plus a half cos 2x plus an eighth cos 4x with respect to x equals the integral of 3/8 with respect to x plus the integral of a half cos 2x with respect to x plus the integral of an eighth cos 4x with respect to x. The first integral is found using the power rule. The second and third integrals are basic cosine integrals given on the first page of this guide, and so the integral of cos to the power 4 of x dx equals the integral of 3/8 with respect to x plus the integral of 1/2 cos 2x with respect to x plus the integral of 1/8 cos 4x with respect to x. This equals 3/8 of x plus 1/4 of sine 2x plus 1/32 of sine 4x plus the constant of integration. You can check your answer back by differentiation. Product formulas. You can use trigonometric formulas to help you integrate the result of multiplying basic sine and cosine functions together by using the product formulas shown below. Sine A multiplied by sine B equals a half of cos A minus B minus cos A plus B. Cos A multiplied by cos B equals a half of cos A minus B plus cos A plus B. Sine A multiplied by cos B equals a half of sine A minus B plus sine A plus B. Usually A and B are multiples of x, and so when they are added or subtracted as necessary, you get a constant multiplied by x. You can use the product formulas to convert integrands which are products of sines and or cosines to additions or subtractions of sines or cosines. These in turn can be integrated using the basic integrals on the first page of this guide. Example: find the integral of sine 5x multiplied by sine of 3x with respect to x. This is a product of two sine functions, so use sine A multiplied by sine B equals a half of cos A minus B minus cos A plus B, with A equals 5x and B equals 3x to help you with the integral. The integrand becomes sine of 5x multiplied by sine of 3x equals half of cos of 5x minus 3x minus cos of 5x plus 3x, which equals a half cos 2x minus a half cos 8x. And the two resulting functions can be integrated using the basic integral of cosine. The integral of sine of 5x multiplied by sine of 3x with respect to x equals the integral of a half of cos of 2x with respect to x minus the integral of a half of cos of 8x with respect to x, which equals a quarter of sine of 2x minus a 16th sine of 8x plus the constant of integration. You can check your answer back by differentiation. Example: find the integral of cos of 3x multiplied by sine of 5x with respect to x. This is the product of a sine function and a cosine function. You can use the formula sine A multiplied by cos B equals a half of sine A minus B plus sine A plus B to help you with the integral. Looking carefully at this product formula, you see that A is associated with the sine function and B is associated with the cosine function. So here A equals 5x and B equals 3x, meaning that the integrand can be rewritten as cos of 3x multiplied by sine of 5x equals half of sine of 5x minus 3x plus sine of 5x plus 3x. This equals half of sine 2x plus a half of sine 8x. These two new sine functions can be integrated in turn using the basic sine integral on the first page of this guide, and so the integral of cos 3x multiplied by sine of 5x with respect to x equals the integral of a half of sine of 2x with respect to x plus the integral of a half of sine of 8x with respect to x. This equals minus 1/4 of cos of 2x minus 1/16 of cos of 8x plus the constant of integration c. Again, using a trigonometric formula has transformed seemingly difficult integrals into two basic integrals, and you can check your answer back by differentiation. Further guidance and information. If you have any further questions about this topic or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. Telephone 01603 592761. Email dos.help@uea.ac.uk, or you can visit our website www.uea.ac.uk/dos/let. There are further resources on many other aspects of mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills.